Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Meta's hyperscale infrastructure, a fascinating look at how they manage their planetary scale operations. It's mind-blowing.
Absolutely. I've been wanting to understand this better. So what's the core of their approach? Is it all about sheer scale, or is there a more nuanced strategy at play?
It's definitely more nuanced. Think hardware-software co-design at a global scale. They're not just throwing hardware at the problem. They're optimizing everything from the data center level down to individual servers, and even the software running on them. It's a holistic approach.
Interesting. So what are some key elements of their engineering culture that enable this?
Well, their culture is built on 4 pillars. Move fast, technology openness, research and production, and shared infrastructure. The move fast philosophy drives their continuous deployment. They're constantly pushing updates, constantly iterating.
Wow, that's intense. How do they manage the risk associated with such rapid deployment?
That's a great question. They invest heavily in testing, staged rollouts, and health checks. They've actually increased their fully automated deployments from 12% to 97% through a company-wide initiative. They're not reckless. They're calculatedly fast.
I see. And the technology openness? How does that factor in?
They use a monorepo, a single repository for all their code. This encourages code reuse and collaboration across teams. It's incredibly open, even compared to other companies using monorepos. Plus, they're big on open source contributions, like PyTorch.
Impressive. What about their approach to hardware? They mentioned cost reduction as a major goal.
Right. They're aiming for all global data centers as a computer, treating their entire global infrastructure as a single, massive resource pool. They use sophisticated tools to optimize resource allocation across regions, dynamically migrating workloads to balance load and minimize costs. It's like a massive, self-optimizing organism.
That's a powerful analogy. And how does their AI strategy fit into this?
Their AI strategy is fully integrated. They're co-designing the entire stack, from PyTorch and their AI accelerators to the models themselves, like Llama. They're not just using AI, they're building the infrastructure to support it at an unprecedented scale.
So it's not just about the software, but also the hardware they design themselves?
Exactly. They design their own servers, network switches, and even AI chips. This allows them to optimize for their specific needs and reduce costs. They even open source many of these designs through the Open Compute project.
Fascinating. What about their approach to serverless functions?
They're huge on serverless functions. They have 2 platforms, front-face for user-facing functions and X-face for asynchronous tasks. This boosts developer productivity because developers only focus on the logic, not the infrastructure. They have over 500,000 servers running PHP for front-face alone, ensuring instant response times.
Amazing. But doesn't this level of complexity introduce challenges?
Yes, absolutely. Managing this scale is incredibly complex, but they've addressed many challenges through clever design choices, like centralized controllers for many systems. Even though decentralized systems are often praised for scalability, they've found that centralized controllers, when designed correctly, can be simpler and make better decisions.
That's counterintuitive. Could you elaborate on that?
Sure. For example, their service mesh, service router, uses a centralized controller to manage global routing metadata, but individual routers self-configure. This allows them to scale to billions of RPCs per second. It's a hybrid approach that leverages the strengths of both centralized and decentralized architectures.
I see. So what are some of the future directions they're exploring?
They anticipate a huge increase in AI workloads, the rise of domain-specific hardware, and a greater need for edge data centers to support real-time applications. They also see a significant increase in developer productivity, driven by AI-powered tools and further advancements in serverless paradigms.
It sounds like Meta's infrastructure is a constantly evolving, self-optimizing system, pushing the boundaries of what's possible. It's truly remarkable.
Absolutely. It's a testament to their engineering prowess and their commitment to innovation. And that's it for today's episode of Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.